what Sandy always talks about is if you can save me what like a gram a week, or is it a gram a day? The
Yeah.
engineer working on something to try to reduce the mass of something. And if they can do that, then you can start reducing the overall mass of your assembly by quite a bit. So small things can add up after a while.
Okay. Cool. Oh, hey, there's I wanted to talk to you about that. So yeah, so I don't want to like spend too much time, with us reminiscing about Zermatt, but that McDonald's right there has a little bit of a story with it. So it was 2018 when I was the one right there.
Yeah.
2018, climbing the Matterhorn, and I think it was the day before I was going to leave to go up there. And oh, look at the horses in the background. That's beautiful. Anyway, I was going to leave to go to the Matterhorn the next day, and Lane went to the bathroom in the McDonald's and managed to drop her phone in the toilet. And because it was 2018, it was the year before they had the waterproof rating on the phone. So we
Oh.
immediately ran. There's a grocery store that's pretty nearby there, and we ran to it and bought a bag of rice and like put it in a Ziploc bag with a bag of rice. But we didn't know if her phone was going to work, so we didn't know if she'd be able to contact me while I was climbing the mountain or not. So
Oh.
quite the story. And by the way, for folks, just real quick, if people are interested in this, this is on my other channel. I'll leave a link to that down in the description so you can go watch it. It's got like 140,000 views, so it's actually quite popular. But it was much hotter
Okay.
than this when I was there, because clearly that is quite beautiful. So you talk for a while so people can see the scenery, because it's
Okay.
gorgeous.
So you see
Yeah.
what just went by me?
It
That
looked like
was an
a,
EV.
oh, it was? Okay.
Yeah. Now, Zermatt has been an EV only city for quite a while.
Right, right. Yeah.
So there are only emergency vehicles or something like that are allowed to be gas powered ICE,
Right.
but everything else here is just electric. And you notice it right away that the air quality is just so much better.
Yeah.
Yes, we're in the Alps where air is already good, but still, you don't want to spoil it by having these vehicles that are going around belching out diesel or anything else.
Right.
So it's really just a wonderful place to come to, and
Right.
we're heading off trying to still get our tickets to the best catered than that, but we got some other things to talk about. So we'll have some nice
Yeah.
background. It's not a sunny day, but we may be able to see a little bit of the mountains here and there. I don't think you can see the Matterhorn. It's probably going to be enshrouded in fog, but
Yeah.
I'll let you know if we do.
That'll be cool. So you also have a story with this, of course, and I will leave a link to this also in the description, because you talked about your cancer, is
Yeah,
the
basically, this is what I call getting back on the horse.
yeah.
Is 2 years ago we were here, and we ended up spending about a day and a half skiing between my wife breaking her shoulder and then a few hours later, me basically getting the indication that I had bladder cancer,
Right.
and then spent the rest of our vacation at a wonderful hospital just down the valley here in Visp. And the medical care here in Switzerland is just amazing.
Right.
And they got me kind of ready then for my surgeries and everything, and taken about 18 months to get me finally cleared. And yeah, so I've decided to kind of come back and finally get a chance to ski a place like we wanted to.
Yay, there
If
we
it's a day
go.
and a half, or get a full weekend. So yeah, sometimes you just gotta face your fears and come back.
Right. There you go. Well, hopefully this trip will go much better than the last one did. And by
Yes,
the way,
yes,
I
yes.
specifically am wearing my Vancouver shirt today because we are
Mhm.
going up to Whistler in March. And I was actually going to go to Zermatt, but none of the rest of my family skis. And so I had a little a long-term plan, which was that we were going to go to Vancouver, where there's very good beginner skiing, at Whistler, and we were going to teach them for the week, and then we're going to go to Zermatt next year to go skiing. So that's the plan. All right, so Scott, so on to the topic du jour. We actually want to talk about this little video that Tesla put out that's 45 seconds. So I'm going to go ahead and share screen here, and people can watch the beautiful background as you're walking. But unfortunately, the way that X works, it's a little awkward to like show this. I can't quite put it full screen. So anyway, this is what I got. But I'm going to try to like let it watch it through the 45 seconds first, and then we can break it down a little. So this is excuse me, this is Giga Shanghai. And you can see this, that's the important part right there. We got stamping, we got logistics. Obviously casting. and on, and body in
And I
white.
think they show assembly in there. Yeah, body in white,
And while
assembly.
they're talking about that, Giga Shanghai is 95% automated. That is very impressive, and cycle time of 40 seconds. So impressive.
Yes, yes, and I mean, just think about that. 95% automated.
Right.
When I sort of heard that, I think, well, wait a minute. What do you need Optimus for? If you're already
Right.
able to do it with traditional automation, such a large amount of it. And
Right.
of course, an awful lot of things have already been automated in automotive plants, like the body and white and paint shops, and those areas had been. But Tesla's been moving on to reducing even some of the automation they need. So if you think about it, when the gigacasting came in, they put a bunch of robots out of business.
Oh yeah.
They're out of a job. So the traditional spot welding robots, hundreds of them suddenly aren't needed anymore. And at the same time, the operators that would have been feeding those robots were also those positions were eliminated at the same time.
Right.
So they're not afraid to find ways of being able to automate, which doesn't necessarily mean you just bring in more humanoid robots. It's
Right.
in some ways they're even going out of their way to kind of eliminate that, and we're going to begin to wonder what sort of automation they're going to be using with Optimus. With Optimus, I assume it's still going to be kind of that low hanging fruit that we've always talked about,
Right.
and that is feeding the machines. And
Yes.
There's still going to be some of that.
And you
There
can
may
see
be
that
some
in
of
the
the
video
logistics.
too, that they're, they're
Yes.
still, by the way, I noticed that they actually had a little timer here and it gets to 39.62 seconds. So that must be their cycle time, because you can see it counting up as it's rolling along. And so 34,
Yes.
35, and then it gets to 39.62 seconds. So that must be their cycle time. Boop. So there you go.
Oh, okay. So they're
Easter
showing
egg.
all the steps. Yeah.
Yeah.
Yeah. Now, the other thing, if you think about it, is that here we have an automotive plant which is 95% automated, and it's in
Right.
China. And
Right.
usually you think of China as like a place that, well, you have a certain amount of automation. They have
Right.
such a large labor force. It's not like you necessarily need to automate because you do not have a supply of labor or that the labor costs are high.
Right.
Right. A lot of times the reason why you automate is because of the quality that you get as a result, the reliability. Every part is produced the same way. So a lot of times that's the real motivation, is that we know returns are very expensive. Your profit margin is wiped out on that product, as well as like a bunch of others you have to sell to make up for the loss on that. So you want to make sure that you don't have any sort of quality issues. And the best way to do that is to automate.
Right.
And they're doing it in China, where you would think there's not as much need for that, but what they want to do is make sure the quality is very, very high. Right. And that's absolutely one way of being able to do that. Yeah. So that's like the other reason you do it is that with the reliability of the processes, they are actually running on a certain takt time. It allows you to get that 40-second cycle time.
Right.
If you have a lot of steps in the process which are not automated, then you have to kind of put in that little buffer for like, they won't always be able to hit the cycle time. There may be a reason they slow down. So that's another reason. So if you want to reduce cycle time and improve quality, automate.
Yeah. And you can see that that's actually specifically what they call out here. That's why they did it. It says enabling a cycle time of less than 40 seconds. It's not any, and of course, as you were talking about, and of course, as Sandy Monroe talks about, it's the cost of quality. If you don't get it right the first time, you have to go back and fix it. And even if that's at the end of the production line, it still gums up the works, right? Even if it doesn't go out, you have to catch it later. Even if you catch it in the final quality check, it's like, well, crap. Now you have to pull that car out of the line. You have to fix it, So
think about it. If you get a 10% margin, and most companies don't have anywhere near 10% margins, they might have like 5%, but 10% on a $40,000 vehicle, okay, you've made about $4,000. Right. So if for something happens that you need to do a repair on a car, you hope that you have to take care of all that for less than 4,000. Once it starts becoming more than that, especially if it's one of these headaches that's going back again and again and again, and you're just pumping thousands and thousands of dollars, sometimes more than the vehicle sold for, to get it fixed. At some point, you have to make the decision, let's just take the vehicle and get them a new one. But in many cases, it may be a lot of companies, they only have about $1,000 margin. And with $1,000 margin, boy, anything goes wrong, and that's eaten up in parts and labor in no time. Towing, anything else, that kind of incidentals that went along with doing that. Right. And if you have a lot, like I say, that means also the margins, not only that you now lost on that vehicle, but on maybe the other 2 or 3, or depending on how bad it gets, 10,
Right.
that you may have had to sell to make up for that. So yeah, quality is very important to the bottom line, and the
Right.
only way to get the quality is to automate.
Yeah. Yeah. And of course, we haven't talked about this at the end here, but from taking 2.5 years for the first million cars, I assume at Giga Shanghai, to the second million in 12 months. Or maybe, yeah. Anyway, but I mean, that's a 2.5 times reduction. That is incredibly impressive
Yes,
stuff.
yes. And part of that is the ramp up of bringing in the automation and
Right.
improving it. So
Yeah.
it was amazing that they were able to start producing vehicles as soon as they did after they built it.
Right.
And then everyone was wondering when they were going to get to these different ramp up rates. And yeah, that's remarkable.
Yeah.
That you're seeing kind of almost an exponential in there as well, as far as how they're able to improve the overall line speed. Now they
Right.
have mentioned they were mentioning something about 30 seconds before, and I don't know if that was aspirational or whether in a couple of cases they've done it. So here officially they're saying 40, but we just heard other people mentioning 30 seconds. So I guess we'd say okay, it's 40 seconds, which is better than most automotive companies.
Right.
Which in the best cases, they might be around like 49 seconds or 50 seconds. Most of them are probably closer to 1 minute.
Right. And so, I mean, I think for people who are just listening to this, they might be like, well, what's the difference between 40 and 49 seconds? That's no big deal. But I mean, you're the person who does this stuff for a living, and I want to actually call out this virtual thing, reality thing in a second. But obviously companies try to shave off 1/10 of a second or something, right? Because when you do it a
Mm-hmm.
million times, the 1/10 of a second adds up really fast, and
Right, right.
much less 8 or 9 or 10 seconds or something. So yeah, yeah,
Right. If you're pumping out some sort of parts and getting a lot of them out there, for sure. So you can imagine like the battery line,
right,
they're trying to get a lot of batteries going through that piece of automation. And if you can do something to speed it up 1/10 of a second and then like multiply that by 1 million cells, well,
yeah,
it's a lot of savings right there in time, or the increase in the number of cells you'd be able to produce over that same time.
right,
And so yeah, they're always trying to shave anything they can here and there to try to get it to add up. Again, what Sandy always talks about is if you can save me what like a gram a week, or is it a gram a day, the
yeah,
engineer working on something to try to reduce the mass of something. And if they can do that, then you can start reducing the overall mass uh of your assembly by quite a bit.
right.
So small things can add up after a while.
Yeah. And so yeah, and so I definitely wanted to call this out though, because you are a big AR VR person, and
Mhm.
this may be the first time that we've actually seen some indication of what they're doing with AR. So this looks like a extended reality glasses where you can see reality, but he's clearly putting on some sort of AR VR glasses, and
Probably
then we
AR,
get
and then
this sort of overlay.
that's
Yeah.
that's the screen. Yep. And then the next thing we see a part sitting in there somewhere,
Right.
and we don't
Yeah.
see
Cool
too
little
much.
fade, and there we go. So some sort of part. Yeah.
Yeah. And it may be that they're looking at how to do the layout. So within a confined space, it's sort of nice to be able to take the CAD and drop it in on top of the real environment you plan on putting it in.
Right, right.
And in
This is
many,
still under logistics here officially. So,
right, right.
yeah,
So it could be you're looking where something is going to be in a. You can imagine in your head where something is going to go, but it's a lot different than if you get the real dimensions. So you
right,
could go out there and draw chalk lines on the floor to get an idea how much it takes up, to get an idea what it's going to be like to walk around there, or what it's going to be like for an operator to grab it and reach these different parts.
right, right,
And in a sense, by doing AR, you can start performing what I like to call these virtual Kaizen events, where you get an idea of what the production flow is going to be and how you can start to optimize it without having to bring physical equipment and move it around. Now you can
right.
look at it, you can see what's in the design, possibly change the design right there, or at least get enough information to go back and change the CAD and then re-upload it. So yeah, these are really useful tools for being able to figure out what's the optimal layout.
Yeah,
And
and
boy, to think about it, it's
interestingly,
like moving into an apartment and it's like, where's the best place to put all
oh
your
man,
furniture?
yeah,
And
that would
in
save so
some
much
cases, you don't know
backbreaking
until you
labor
move
on
it
a
in.
personal level to
Right,
not have to keep moving
right.
the couch around. So yeah,
Right. And I don't know if you ever did it. As an engineer, I used to do these 2D layouts on graph paper, and then kind of get the idea of the top view of all the furniture we had, and
right,
then move it around that way. So that was like the poor man's CAD of figuring
right.
it out. So those have been sort of the tools that have been used in the past to figure out layouts in factories, and then then we moved to CAD and more advanced CAD to make it easier and easier. But now
Right.
if you can actually walk into the real environment and say, oh, let's imagine this piece of equipment right here. Let's imagine
Yeah.
dropping this robot right here. Let's get an idea of what the operator ergonomics are going to be as far as, how many steps do they have to move? What are their sight lines like?
Right.
If we have to do maintenance, can we actually get access back in there? If we have to do maintenance, is it too tight? Are we within, let's say, the OSHA regulations as far as clearances for being able to walk around different pieces of equipment? And
Right.
a lot of times your CAD may not even have all the data that you need. So services and stuff like that, sometimes it's missing in the CAD. You assume, oh, we can drop this in and go out there. Wait a minute, what's this pillar doing here? We weren't
Right.
expecting that. So yeah,
Right.
you have to double check and triple check to make sure everything is exactly the way you expect it.
Right. And here you can see that, of course, because there's a 3D object. It looks like it's some sort of pull cart because I see wheels on the bottom of it. But
Mm-hmm.
yeah. But I don't know exactly what he's doing, but maybe it looks like there's the back of a truck coming in here too. So
Could
maybe
be.
it's like
Yeah,
whether this
could be.
thing's going to fit inside the truck and how it would work in terms of that. It's a little hard to tell because it just shows up for, I mean, I think it's gone. Yeah, that's it. It's
Yeah, they
there
don't
for a
show us
second
very
or go.
much. Yes,
Yeah.
unfortunately, you just kind of notice like, aha, they're doing some sort of AR, and that's it. They won't show us anymore. And so they're probably using the AR to help them out in the logistics. Well, the idea is that you have maybe these carts that are already filled inside of there because the trucks are being used as kind of like your local warehouse.
Right.
So the
Right.
parts come in, and you don't unload the truck to an internal warehouse. It remains as the warehouse until you empty it out. So they may be looking at better ways of being able to load up these carts and get them out to where they want. So I would not
And
be surprised
that's a
that
really
they're
cool
probably
thing
changing up the
too
logistics.
that Tesla does is that they have bays all around their factories. And we could see that at
Mm-hmm.
Giga Texas. They're not just at
Yep.
one side and they pump it all in and then they have to warehouse it inside the factory. They just use the
Yes.
back bay of the truck as the semi trailer as the warehouse. So
Yes. Yep.
very cool.
That's it. Yeah.
Yeah.
Yeah. And it turns out to be more efficient. The other thing is to make sure those bays are very close to where they need to be.
Yeah.
So the distance you need to move from that truck to where the part is needed is very short compared to the traditional way where it may be on the other side of the factory, and you got to figure out how to move that stuff around, and you
Right.
get all kinds of congestion and everything else. So yeah, this is a much better way of making sure that your components are near where it's needed,
Right. And I would
as well as
imagine
not having
even
to actually build a warehouse.
yeah, and even traffic flow of the trucks and things. Because again, if you have like, 18 bays on one side, you've got these trucks trying to get in and around each other. But if you just have them sort of spread out, the truck just drives to where it needs to go and they're not fighting with each other
Right,
again.
right.
Yeah.
And then
So
internally, you get the problem with the forklifts that are driving around.
right,
They
right.
have to
Yeah.
drive from one side of the factory
I
to
worked in a
another.
warehouse. I worked in a warehouse one summer, and yeah,
Crazy.
the forklifts are
It's
dangerous too
it's
because they're flying around, and as a person, you're like,
yeah.
geez.
And
So yeah,
and we've done a lot of simulations for clients where they're trying to understand the issues with congestion as they start moving these forklifts around to take care of all the logistics they have.
yeah,
And in a sense, they almost have to set up what looks like a train or bus schedule where they know the parts that they need to have. They load them up on their trolleys and then they drive them out there and they are on a specific schedule. This trolley leaves at 12:03 and heads
right,
out there and does what they call the milk run to go around and drop off the parts that are needed and pick up all the empty milk crates or milk jugs, if you want to think of it that way, and bring it back to the warehouse for recharging for the next run. And
right,
so they're constantly working out those logistics and then finding that we aren't able to make that run in the time we thought because we had a lot of congestion because there's all these intersections across through lunch shifts where people are walking around getting in the way. And
yeah,
of course, the way they want to optimize it, you want to have the fewest number of forklifts as possible because each one of them costs you money.
yeah,
In
yeah.
many cases, these companies are actually leasing the forklifts. They don't own them outright.
This
So
this
yeah,
gets into
if
it
you can
starts
get
to
rid of
get
that
into the
headache,
weeds, and you start to realize just how
right?
insanely complex this stuff is. When you start
It's very
building
complex.
out. Yeah,
Yeah.
yeah.
Yes,
And of
yes,
course,
yes.
if any of those things breaks down, or if the driver has to take a bathroom break or something, all of a sudden all that schedule goes out the window anyway, and you're back to like, it gets crazy. So
Yeah.
yeah,
Yes. Yeah. Yeah. And you've got to always come up with contingencies. And yeah, there's a lot of people trying to optimize that problem. And in a sense, by changing the configuration completely, you don't have to optimize that old problem. You've now, solved it a completely different way by
right.
making sure the parts are where they need to be.
Right. And here I was just noticing a lot of very, very rapid stamping that we're seeing here.
Mhm.
And then of
Yeah,
course we
and
get to the
that's been
casting,
automated for a while. Now, believe it or not, that
which is
stamping
cool.
line you see there,
Yeah.
that used to be very manual. I remember back in the
Oh,
80s
interesting.
visiting a couple of those plants, or yeah, the sheet metal. was
Yeah.
loaded into these stamping presses.
Right.
And then, they would go down, come up, and someone would pick up the piece of sheet metal and move it over to the next one, the next one. So
Right.
what those robots were doing, that had to be done manually. And everyone was like, wearing this incredible ear protection stuff and everything else. And you had to keep up with the press because these presses, once they get going, you can't stop them. There's just, and you need to make sure the sheet metal is in there. And it's a very stressy job for operators going ahead and doing that.
Right.
And so they automated that years ago by having these robot arms that go in there. And you'll see those robot arms. The other thing is they couldn't run those presses all that quickly because you had to make sure the operator had very good clearance of their arms are out of the way. Right. But now with the robot, that press is actually coming down while those arms are still in there. One of them is still extracting one piece of sheet metal while the other one's going in.
Right.
That's how you get the cycle time now. That's not something you can do manually.
Yes.
That's something you have to automate. And so they were looking at sort of specific pieces of automation equipment for it. And in the end, it turned out just taking some standard robot arms and making some slight modifications on them. So they have like this kind of extended gripper that's able to go in there and do everything else. In some cases, I think might be just like a 5-axis arm. But basically, they are your industrial robot arm with a little bit of modifications to be able to do press bending.
Right. Yeah. And then I want to be respectful of your time because I know you want to go get your tickets and stuff, but also we get casting here. So this is cool that we get to see some of the giga casting procedure. Looks like that's the molten metal.
Again, yes, again, that's, that you want to automate that because not only is that a very heavy part, it's a very warm part, I guess you can say.
Yeah.
So, and you want to get them out there as quickly as possible and you want to do it reliably. So you could just keep that press going and making sure that you're coming out with the castings. You have to produce those castings at least, every 40 seconds.
Right.
Or maybe faster, depending upon how many casting machines you have, whether the castings have to produce more than one type of casting.
Right. And really interesting stuff. Like this robot here is obviously on a track where it's moving things back and forth across a track. This guy's dunking it in the water.
Yep.
So
I think they're doing a little bit of a quenching there. So I'm not sure if it's water or actually oil mixture or some sort.
Clearly very hot. Yeah. So
yes. So they do a quick quench,
right,
and then it moves on. Yep.
Yeah. So the
robots might be on a track. Yeah.
Yeah. Okay. Yep. And then the quench, and then yep. And then of course all automated, so you don't have to have people picking up giant parts like that. That would be crazy.
Yeah.
Yep. And then body in white. So now it's building it. So yeah. So this is where you could imagine most of the stuff at the beginning. It looks like it's completely automated, but somewhere around final assembly is where the Optimus robot might come in. Because I imagine most of the human labor is probably.
Yeah, notice. I mean, that there used to be something that I think was being done manually with a lift assist, and now it's being done completely robotically.
Right.
And then we got the general assembly
is where you see a lot of people. So this would be the place where Optimus could come in. Still,
Optimus and unboxing.
Yes.
Unboxing will make that a lot easier too.
Right. Because you can see that here that you've got, the car is somewhat complicated to work around right now because it's so if it was unboxed and you could work on the individual parts, it would be somewhat easier. So yeah.
So much easier. Oh yes, absolutely.
Sorry, not somewhat easier, so much easier. Yep. So yes.
Yes. Okay, so there we go. I think you're hearing the church bells, right?
Right. Yep. It's 2 o'clock for you. So I'm going to stop screen sharing so we can see the church was so beautiful back there. This is really bringing back memories. Of course, it's much colder than when I was there, but it's, and there's the horn. Yeah. Wow.
Yeah. I thought you'd like to see the horn. It's over there.
Gotta get back. Yes. Yeah.
Yep.
And anyway, so
I don't think it's not a glockenspiel, but it is just the bells.
Right. So we, it wasn't the Kleiner Matterhorn and it wasn't the Matterhorn. It was over across the valley, but that's where we did our, what is it called? Paragliding. Jumped off the mountain basically with a parachute. That was fun. Yeah. A really bluebird day. It was really beautiful that day. Anyway, but how's the weather? Is it below freezing? So you're getting good snow?
Yeah, it is. It is. So we made it up above the frost line when we came up on the train.
Okay.
So down the valley, it's wet. In Zurich, it was still kind of wet and rainy.
Right.
But up here, it's coming down a little bit of snow, but very foggy, as you can see.
Yeah.
Yeah.
Quite beautiful though. Well, okay,
Yep.
so I will let you go, Scott, because I know you got to go get some tickets. Thank you so much for taking time out of your ski vacation to talk to us and letting us all see a little bit of Zermatt. And hopefully send some
Okay.
pictures of the Matterhorn and stuff if you get a nice blue day.
Oh yeah, when I get up on the mountain, I'll send you some nice pictures.
Cool.
Maybe we can do a video from lunch up on the mountain.
Oh, that would be nice. We can always add a little addendum at the end in that case. So,
Yep.
all right. Well, enjoy yourself and have a great day.
Yeah.
And you know, everybody like, subscribe, follow Scott. I'll put all that stuff in the description. And everybody have a lovely day. Bye bye.
Yeah, and I'll be the same.
Treat the same.